So we've been doing a lot of derivatives. I mean, the majority of this course is taking the derivative, and now we're going to go in reverse. And the reverse of a derivative is what we call the antiderivative. So we're undoing the derivative essentially. So in general, for any power function, which is a variable base expression with a numerical exponent, when we take the antiderivative, what we do is, so the antiderivative of little f of x becomes f of x. So just have to be careful there with the notation. It's a little confusing. But what we do is we take that exponent of n and we add 1 to it. Then we divide by the new exponent. Then whenever we take the antiderivative, keep in mind that your original function could have had a constant. And what happens when you take the derivative of a constant is you get 0. So to take into account the fact that the antiderivative could have had a constant is we just add c. So it just kind of takes care of that part. It could have had a constant, it could have not have been, but we just want to make sure we cover all our bases in terms of our antiderivative. So anytime you take the antiderivative, you must add the constant c, where obviously c is a constant, so it's just a number, okay, because the original function could have had a constant. So let's try some questions in here. So when I take the antiderivative of small f of x, I get capital F of x. So when I take the antiderivative of 6, well, I get 6 times x. Now how I got that is go in reverse. If I take the derivative of 6x, I get 6. So the antiderivative is 6x. Then I'm going to subtract 2 times x to the power of, well, that was 1. So I'm going to add 1 to the exponent. I get x to the power 2 and divide by that new exponent, which is division by 2. Then we're going to subtract x to the power of, add 1 to the exponent, gives you a new exponent of 4, and divide by 4. So there is my antiderivative, but don't forget that your original function could have a c value, so we want to add a c value after that. So just to simplify this, the antiderivative is equal to 6x minus, these two's reduce, so I get x squared, minus x to the power of 4 over 4 plus c. So that right there is the antiderivative. Let's try this question right here. So antiderivative of small f of x gives me capital F of x. So the constants, the coefficients, as you notice, are going to stay exactly the way they are. So 7 still is there, but I'm going to attach an x to it. Then I'm going to subtract. 4 stays the same, and then I'm going to raise the 1, add 1 to it, get 2, and divide by that new exponent, get 4x squared over 2, plus 6x to the power of 3 over 3, and then minus 20x to the power of 4, and then divide by the new exponent, which is 4. So, and then, oh, don't forget, I almost forgot here, add the constant c that could have been there, okay? So f of x is equal to 7x minus 4x squared divided by 2 gives you 2x squared, plus 6 over 3 gives you 2x cubed, minus 20 over 4 actually reduces to 5x to the power of 4 plus c. So there is the antiderivative for both of these polynomial functions. So next lesson I'll talk more about the differential equations and the indefinite integral.